Hello everyone, welcome to the UC San Diego Makerspace. My name is Mark and I'm one of the engineers here, and today we're going to talk about cutting metal on our Fablight laser cutter. So why don't you come in with me and we'll show you how to get started. So this is our Fablight metal laser cutter. It is a fiber laser cutter, which is slightly different from the CO2 lasers you've probably used before. The main difference being that the laser source is from fiber optics wrapped around rare earth metals. This produces a laser at a different frequency than a CO2 laser, which means that it can penetrate metals of varying thicknesses. This also means that the laser cutter is not compatible with woods or plastics. So you cannot put any of those materials into this machine. Those will be reserved for our CO2 lasers. And today we're going to show you the process how to cut metal on this machine, and you're going to learn that it's just as quick as easy as our CO2 lasers. Traditionally, the main materials we cut on this machine are aluminum, steel, and stainless steel. For aluminum, we cut alloys such as 6061, 6063, and 5052 usually, and you can cut those up to 3/16 inch thick. For steel, we'll cut cold roll and hot roll steel, and you cut those up to 1/4 inch. And then for stainless steel, we've cut 304 and 316 up to 3/16 inch as well. Those are the only materials that are permitted in this machine. If you want to use a different type of material or have an odd thickness, please ask our staff members for help and we'll let you know if you can or cannot do it. The biggest thing about this machine is that unlike our CO2 lasers, you cannot experiment with the settings, so that the materials that we described are the only materials permitted in the machine. So the first step to cutting on this machine is having your file ready. You need a DWG or a DXF file. Now this file can be generated from a large variety of software, including SolidWorks, Fusion 360, Illustrator, Inkscape, and more. So once you have the file, we're going to go to one of our computers and we'll set up your cut. Okay, so once we get onto a computer, the laser cutter software is called Fab Creator. You want to open that up. Like I said, we have that installed on all of our workstation laptops as well as our laser cutting computers. The first thing we're going to do is import our DXF by using this import button right up here. Now once you open your file, it's going to ask you if it's in inches or millimeters. We're going to do inches, so we're going to select that. You'll also notice that you only have two choices right here. So your file has to be either in inches or millimeters for the computer to recognize it correctly. It cannot be in centimeters, meters, or parsecs. So you can see here it brings in our file. Everything looks pretty good. The software will try to guess what you want engraved or cut. Unfortunately, it usually gets it wrong, so we're going to make some small adjustments. Here on the left, you're going to see the 4 different types of lines the computer will recognize. Green will be for cut. Red will be for engrave, where you're just vector engraving the line. Blue will be for the raster, where you're filling in the space between the lines. And then the black will be just lines that are using for reference, which will be ignored by the laser cutter. This is handy for things like moving the watermark from SolidWorks into. Also for things like you don't want cut or engraved, you can select, hit delete, and it will delete them. We're going to undo that. That's also useful for software that produces watermarks in your files, like SolidWorks. So for my part right here, we're going to select all the text lines, which I believe are these. Now we're going to move them into the blue folder for raster engraving. So now it's going to fill in that space with a engrave. It's going to then do a vector engrave on my red line right here, and it's going to cut out my part outline. And that's exactly what I want. Once you've managed to set that up, we're just going to go across the top tabs here. Next step is going to be to edit. Now what the edit does is it lets you move the part or rotate the part in case that your orientation is wrong in the software. It also lets you set the origin of the part, which on this machine is always going to be the bottom left, so that's what you want right there. And then you can also edit text. We find the text editing feature in the software pretty poor, so I don't recommend using it. I would always do that in your editing software before importing your file. Okay, so next in our Properties tab, we're going to have our cut parameters. These are very important, as if you use the wrong settings, you could damage the machine. So the machine itself is at 4500, so we're going to select that. Our units are in inches. And then the material type, we're going to select a sheet. Now, this machine does have the ability to cut round and square tubing. That will be talked about in a part 2 of this video. For material, we're going to do steel. We got our choices between aluminum, stainless, copper, and steel. Today we're cutting steel. And then material type typical. Now the thickness is really important. You have to use the right thickness or else the machine may not cut your part properly, and then it can also damage the machine if you use the wrong setting. So today we're cutting 1/8 inch steel. If your material is within about 1/10 thou of the thickness, it'll work just fine. If you have any material that's an odd thickness that is not in the database, please reach out to one of the staff members and we'll help you get sorted out. It's going to give our X and Y size of the part, and then it's also going to set our engrave settings and raster settings to their default parameters. A note on a raster setting, you want the X and Y DPI to be the same number. Well, I'm not exactly sure why the computer defaults to different numbers, but you want them to be the same so that the cross hatching looks even. Now, I would also not go past 625, as going higher than that will just make your cut take dramatically longer without giving you any benefits on quality. I would also not go lower than 200, because past 200, lower than 200, you get quality issues. Once you're done, you're just going to hit accept, and then we're going to go on to the next tab. Next, we're going to talk about tabs. Now, the machine bed has slats that are about 4 inches apart. This means that small parts will like to fall through, which means that you have to go, or parts that are long and small might sit on one of the slats and tilt up when the machine is cutting. Now, this causes an issue where the machine nozzle may hit the part, which can cause damage to the machine as well as ruin your part. So to solve those two issues, we use tabs. So we're going to place about 3 tabs on this part, 2 on top, 1 on the bottom. I find that 3 tabs is basically good enough for any of these types of parts. And a default tab length of 0.01 inches makes the tab small enough so that you can hit your part out with a hammer. And hit done. And then you also want to leave curved compound that offsets the beam of the laser cutter. 5 thousandths is a good number for that, and with that, the laser cutter produces really precise parts. We're going to job. You can hit job preview. That's going to show you what the part's going to look like. As you can see here, the laser engrave filled in our text lines, which is perfect. And then step and repeat will let you multiply your parts so you can do more than 1 cut. After all that's good to go, we can check to make sure we got the right settings down here. This will tell you that our job will take 11 minutes and 16 seconds. A large chunk of that time is the engrave. I also want to note that when you're cutting thicker material like 1/4 inch steel or 3/16 inch aluminum, the machine does take a lot longer than cutting, say, 1/8 inch. We're going to hit make and save the file onto our flash drive. So once you have your file on the flash drive, we're going to go over to our machine and load the material in. The first step to loading the material in is opening the front access door and pulling out the tray. This is the tray I was talking about earlier, where it has slats every 4 inches. This is where your material is going to sit when you load it into the machine. So if your material is relatively large, you can just set it into the tray and not have to worry about clamping it down. Today we're going to be cutting on this sheet of steel right here, so I'm just going to grab it and put it down in the middle. And another thing I want to note, that if you have a smaller piece of material, such as this piece of steel right here, you're going to want to actually clamp it down to that bed. And how you do that is that we have these little clamps down here on the side. Going to loosen these clamps, and slide the material in, and then you're going to clamp them down. You don't have to worry about the machine cutting into the frame of the tray. There are software limits to prevent that from happening. Okay, so once you're happy with how your material is situated on the bed, you're going to want to slide the tray back into the machine. Now when you do this, you want to make sure you get the bed locked into the first detent, and you're going to feel it when you slide it in. Now if you don't do this correctly, the machine will give you an error when you try to start cutting, so you'll know to have to readjust. Once you got your tray situated, we're going to close the front door up. One thing I will note is that while this handle looks like a really good place to rest your hands, I recommend not doing so, because if you accidentally pop the door open at all, the machine will automatically shut down during a cut as a safety feature. So once you've loaded material in, we're going to go over here to our control panel and plug in our USB drive. If the control panel isn't on the home page, there's a back button or a home button in the top left corner. Once you're there, you're going to select new job. And once you select new job, it's going to find all of the Fablight files on your USB drive. As you can see, we only have one, so we're going to select that, and we're going to select file. It's going to copy the file onto the machine's computer, and it's going to show you all your different types of cuts. As you can see, we got a raster, which is going to be our engrave. We got the engrave line, and then we got the cut, which is exactly what we wanted. It tells you the time and also some of the settings the machine's using. You're going to click the green check mark in this right corner. So now on the next screen, we're going to be able to move the laser cutter head where we want in relationship to our material. Now you'll remember that in the laser cutter software, we set the origin to the bottom left corner, so that is where you're going to want to position the laser cutter head. To do so, you can drag these blue boxes around, and that's going to move the laser cutter X and Y. Now, if you want some more fine control, you can double click any of these boxes, and it's going to give you a numerical keypad to type in a number. So we're going to go from, say, 9.8 inches to 9 inches exactly. And we're going to do that for the X-axis as well. Now, once we're happy with how the laser head is positioned with our material, we hit Run Job here to load the file, and then it's going to flash this green start button, and you click that to start the laser cutting process. If anything goes wrong during your cut, we have this big e-stop button for emergencies. You can also hit the stop button, which will pause the laser cutter. So when a machine is cutting, you want to be paying attention and watching it. The two main things that can happen are if the machine doesn't start cutting through right away, you want to hit the stop button immediately. This could damage the machine, and it's usually a problem with your settings. The other thing that can happen is as it's cutting, parts can sit up at an angle or jackknife, and that provides an opportunity for the machine nozzle to hit something. And again, if that does happen, you want to stop the machine. Now, if you have any questions about this or you're worried about something, definitely feel free to ask any of the staff members and we'll happily assist you. Once the machine's done cutting, you want to wait about 30 seconds for all the particular matter to settle before opening the bed. After you've waited for about 30 seconds, you can open up the machine and look at your part. So once you got the material out of the machine, we're going to grab this here. I'm going to put it down on this foam block we have on these tables. Now, if you remember, we tapped a part in, so that's why it's not coming out right now. And how we're going to get it out is we're going to hit it with a hammer. So we got our hammers in our tool chest over here. You're going to grab a hammer and just whack your part a couple of times. Or once, and it's just going to come out, and you're all ready to go. Once you get your part out, you may notice on the back side there's going to be some burring. You can go into our metal shop and use either a file, sandpaper, or a grinder to smooth that out if you need to do so. Before you leave, make sure you put all your stuff away, your tools away, and close up the machine, and then have a wonderful day. Thank you for watching, and I hope you learned something. Oh, and one pro tip, don't forget your flash drive in the machine.